All right, everyone, here is the first video in regards to the winch bumper for the 12 valve. I have never worked on a Gen 1 Dodge ever, so I was happy to see how decent they made the frame on these. I didn't really know what I was going to get into until I got the bumper pulled off. I think we'll be in pretty good shape. I have a plan to strengthen up the front end, which I think is the first step whenever you're trying to design a winch bumper. In broad strokes, eventually, this is going to have a pre-runner look, sort of. We're going to do 2-inch diameter tube, quarter wall, and it'll be bent with a tubing bender to complement the body line. And then we're going to bring another one like this down to here. And what we may do is have it protrude a little bit below the winch, or below the winch bracket, winch plate, winch bracket. I had this bent at a local metal shop where I get metal from, local metal distributor. They have the capability to bend very wide. I mean, this is nothing compared. They could probably bend something 8 foot wide with their fancy press and shear and bender, I should say, press brake. So what I asked them to do, I pre-measured this and I added a little bit on each side so that I'd have some room to weld the mounting plates that I will get into in a minute. And I had them bend a 90. So in the first shot, before we even start, we have ourselves our fair lead mount. So we're going to cut an opening into this to bolt our winch fair lead in here. Now what I'm using is a Generation 1 Smittybilt X02 12K. I had this sitting around. I intended to build a bumper just like this for my 02 Chevy 3/4 ton 6.0. We're going to use it on this because I'll try out the Gen 2 for the Chevy. You know, no big deal. One of the things you might want to start with is, do things physically fit? And if the winch were to break, could you physically replace it? Now, the way this is set up, I could unbolt it, tip it forward this way a smidge, and this whole thing will come right up. Our electronics box fits just fine up in there. We'll have it perfectly centered. It's not perfectly centered right this second, but you know, it's there. I like having the winch up where you can see it. I like having it so that it's not down, getting dirt and everything on it. If you put it too low, you're going to take away from your approach angle. Now, eventually, we are going to straight axle this truck, but this is step one. The front of this truck it hit a deer. I have to readjust that headlight or fix. Actually, it looks like it's got zip ties holding it down, so I need to figure that out. But this side was really screwed up, and the bumper was really screwed up. So maybe I'll put a picture there of this in there. And the wind is really honking, so if you hear any kind of noises of wind hitting the building, it is what it is. It is blowing here in Michigan today. So first step is make sure that you can physically access your winch. And can you replace it? Can you remove it if you have to replace a component on it? And could you put a new winch in here from a different brand, a different model? And I think the answer is yes to all those. I think a 12K winch with pretty sure it's 4.5 by 10 is the standard bolt placement for a mid-sized winch, not a large frame, like a 16,500 pound winch. That's the next frame size up. And I don't know, it's probably 5.5 by 12 or something would be their feet or their bolting surface for that next step up winch. This would be common size with like a Badlands 12K, a Warren 12K, even a 10K. I'm pretty sure 10K and even 8,500 pound winches, I think, share a similar footprint. But they're going to keep getting bigger on their sides. They're going to keep getting bigger in all dimensions. I mean, they can. This is a pretty compact winch. That Badlands Apex that I have is, I think, bigger footprint than this. It looks like by a sizable amount. So something to keep in mind, the Winch brand, sometimes the cost that you might save at a different company went into making something more compact. So I think that this is maybe a couple $100 more winch than the Apex, and so far I haven't had any trouble with the Apex. And I actually think that I like the Maybe. This is perfectly fine too. Our selector for free spool versus line in. One of the other considerations you might need to have is where do you want this fair lead to be placed up and down? Now that conversation may also include what other attachments are going on here. We're going to put our towing eyes for our clevises slash soft shackles. They're going to be out here, and they're going to connect directly to the frame. We'll get to that. Give me a minute. Your consideration might be, where do you want to have this opening relative to the drum? There probably isn't a wrong answer. You could put it up high, you can put it down low, because the line is just gonna run on the lips, and it's gonna center itself up. What I like to do is put it somewhere halfway in the middle between an unspooled portion of line. So the last bit, last say 5 feet of pull, you're not really dragging hard on something. And the last 5 or 10 feet on the spool at the very bottom, when you have the least amount of spool on there, the winch line would be the highest versus what I just stated would be the lowest when it comes out of the bottom of the spool. I try to find a happy medium between the two, so in both extremes it's not hard on in either way. So that's how I like to do it. Now to cut this out, we could use a plasma cutter, we could use a die grinder. You could, if you wanted to, I suppose you could niche the whole top out, or actually come down farther. I don't want to do that. I'll probably end up plasma cutting it is probably what I'll end up doing, so that way I can plunge in and remove just a square portion. You could also use, one of the other things I've done before too, is I've used like a big metal cutting 2-stroke saw. My dad has a steel, it's like a cement saw, but we have a metal cutting blade on it. We usually use it to cut apart frames or cut cars in half or whatever. It's a really awesome tool, and you can plunge really well, especially something this size. You couldn't go too much smaller, because the diameter, the working diameter of the saw, when you plunge it in, if it's too much skinnier, you're not going to be able to actually cut through it. But I usually go, a smidgen wider than it needs to be, so that way I can plunge straight in. And then you could clean it up once you get the bulk of the cutting done with like a die grinder, or you could probably use a Sawzall if you really had to with a metal cutting blade. There's a lot of different things you could do. I think we're gonna use a plasma cutter just because we have it, and we'll plunge in. We'll start maybe a cut here and then, like that. So we're gonna have to drill bolt holes to put our fair lead bolted to it. Now this is where the meat of the potatoes of the planning video. So we're gonna call this video 1, and that's kind of the planning video. One of the things that I think bumpers in general overlook is the strength of where they're being mounted to. The front of vehicles, now this truck was built way before crash safety, crumple zones and all that stuff was a thing. This is kind of more like a 70s, 80s style design. This truck was outdated when it was launched in terms of its frame design, cab design. It's kind of like a car. First gens are literally like, they feel like you're driving a car. It's kind of weird. So that's a good thing for us. We have a relatively strong set of frame rails to use. We don't have any crumple zones on them that I can see, but we're gonna have to armor this up somehow. And I drew a nice little drawing we're gonna go over to in a second, but I wanted to give you an overview looking at this, what I would like to do. I think we're gonna, first of all, start off by grinding all of this and make all this metal clean using wire wheels, grinder, everything. Make this whole, both of these front frame rails clean. Inside, outside, top side, whatever. What I'd like to do is I'd like to take a 2x2 quarter wall piece of tubing, and I really square, so I guess not tubing, but we'll call it tube just for communication reasons. Square tube. I like quarter wall square tube because it's ridiculously strong. It really isn't that heavy, and once it's there, you just kind of forget about it being there. And in this case, it's exactly what we're gonna do. A lot of times working on a newer, like a 3rd gen Dodge or like a Super Duty, when you go and put like longer travel, better suspension on it, you can end up, and also with like heavy duty steering gear and whatever, you can end up separating these frames from the load of the steering gear pushing that way on that steering gear when you're turning to the left, and pull it this way when you're turning to the right. Does that make sense? Yeah, should make sense. Good enough. What we're going to do is we're going to tie these two frame rails together. And we'll talk about one of the other bumpers I built that's in the garage right here on my Cummins, on my 03, 3rd gen. It is a 1-ton, doesn't have crumple zones. It was a dying breed before they started going to corrugated frames and all that stuff. So that's kind of cool. One cool thing about that truck. So we're gonna take a 2x2, we're gonna bridge it across. And my plan is hopefully to beat it in with a hammer so that we kind of pre-spring everything out. So it's not just gonna sit in there, it's gonna have some force pushing either side so that we're really gonna hold those two frame rails apart at the same distance. We're gonna burn it in all the way around. The other thing we're gonna do is we're going to cap the end of this with a piece of quarter wall, same material that the plate's made out of. This will be where we bolt using, I don't know whether we're going to reuse, in fact, I'm going to call my dad and ask him. My dad is a mechanical engineer. I am rather knowledgeable, and I did study mechanical engineering for a while. I have a bachelor's of science in business administration. However, I do have a brain that likes to think engineering. My dad is, in fact, a mechanical engineer, has designed many things relating to suspension, chassis, cooling, systems like that. He's rather knowledgeable. I was going to ask him what he thinks about how I should arrange the bolts in this. Because of the space restriction, I'm planning on putting 2 bolts per side. So we're only going to have 4 bolts to work with. And what I'm curious about is, do we stagger them? Do we put them in a row, or do we put them vertical? In theory, we're going to be having, in an accident, which we're going to avoid having, the force is going to go in like this, and maybe it might have an upward force too, because in theory, you're going to be hitting something that is shorter than you. So we're going to have an inward and an upward force if you're going to be in an accident. And also, if you're off-roading, you run into something, most likely once this thing is straight axled, you're going to be hitting something that's lower than you, so it's going to have an upward force. Or if you were to drop the truck down on something, you're going to have an upward force to contend with. When we're winching, we're going to have a force pulling this direction. And you could have some lateral forces side to side, which is why that cross beam is going to be so important to tie the frame rail together. So that way we're not going to try and skew our frame rails either direction, okay? So that will allow us to be on this side. Now here's one thing. This is a C channel. And I'm going to show you, I drew a nice schematic here. I don't normally draw things because it's kind of all up in my head. Excuse me, but I've been drinking coffee this morning, so excuse my burp there. We are going to turn this into a fully squared, fully boxed section. And more importantly, we're going to take some of this nice 1/8 Electrowall tube. This looks like 1 1/4 or something like that. I think it's 1 1/4 OD. And we're going to use that to have spacers in here so that when you tighten the bolts up, you don't crink it together. We're gonna have spacers in here. So we're gonna have one piece of this material right here. And right now it's in long form. And we're gonna run it from the bolting surface to here. But what we're gonna do is we're gonna bend a 90 in it, and we're gonna bring it back this way. So it can be butt welded right here, but we're also gonna drill some holes in it so we can plug weld it. So the one piece will go like this to here, and I drew it all, you'll see in a minute. We're gonna take 2 of these round tubes and put them in here to space over. We're gonna take another one of these, and we're going to come like this, and then we're gonna turn it back on itself. We're gonna use some of this stuff right here. This is 1/8 wall, similar material. This looks like slightly bigger than 1/8, but it's gonna be fine because we're gonna be in compression here to fully box the frame. And what we're gonna do is, we're gonna cut a niche out of the end of this, little square 2-inch outer dimension part, so that it engages on this cross beam that's gonna go in here. It's gonna kind of finger right in like this, but it's gonna be square. So I guess it'd be more like this. That way, we take this frame rail that's sticking out here, and we bring the structure to this big heavy duty 2-inch quarter wall piece of material that is over here. So that's what we're going to do with that. And by doing that, we're going to tie the two frame wheels together. So we're going to help ourselves in the steering department. We're going to help ourselves in the front end strength department for not only the running a solid axle, but also, I mean, abusing it off-road with a solid axle is, I guess, what I'm getting at. But also when we're putting side load on the winch, and hopefully whatever orientation we choose to do the bolt holes, whether we choose to use the original holes or whether we choose to drill new ones and potentially fill the other ones, we will make these stronger by having them fully boxed and tying them into there. And then when we connect this, so it'll be bolted on, we'll have this portion, we'll have this portion, and they'll be cross-bolted together. So that is how we're going to run this, I think, hopefully. Let's go over to the table and we'll look at the drawing I did. Maybe that'll make it a little more clear. So hopefully we don't make this clear as mud. This is how we have our original frame rail. It's a C-channel with 2 holes in it. Now I drew it like we're gonna have stacked holes because I think that's what I'd rather do. But we'll see if we end up doing inline holes. That doesn't really matter too much at this point. So this is it duplicated right here, except for with our 2 tubes that are going to keep from crushing this unit when we put load on the bolts. And then this is our outer face that's going to plate that off. Then I came over here and drew what it's going to look like. Here's our square tube. Then this is our gusset plate, if you want, or our plate that's going to make our frame rails at the very tip of them fully boxed. Here's our winch plate right here. 1/4 inch winch plate. We have our holes. So then this is our outer cap, or outer bracket if you want, that's going to be bent so that we can weld vertically here and then all the way down the length of it here and on the inside too, should we want to. And then we have our next piece that's going to run on the outside, bent and engaged. Both of these are going to have holes in them to plug weld them. This one, the outer one, will plug weld directly to the winch bracket. And then this one will plug weld and weld directly to this one's leg. That allows us to be able to burn a weld right here and right here. Sorry, I'm looking through the screen trying to draw. So that'll be incredibly strong. And then we have our cross tube right here. That's tying the 2 frame rails together. And I just duplicated on this side, and this corner insists on being peeled over. My God, stay put, man. So hopefully this makes it a little clearer than mud, what I'm planning to do. I hope that makes sense for you guys. And yeah, if you have any questions, this is kind of the way that I approach when I make a winch bumper, and this is how I'm approaching making this specific one. I haven't made a pre-runner style tube style winch bumper ever. I made a really sweet one for the excursion. I'll post a picture. And then we'll walk over right now and look at one of the other bumpers I made. This one was not made with a winch, however, I'm going to retrofit a 2-inch tube to it so that I can hook my winch mount that you guys saw me build for my trailer. That also has a 2-inch receiver mount option on it. So that way I can use it on my big Cummins or my 3rd gen. And that way I don't have to have a heavy winch hanging off the front of it too. Mostly because that truck, I think, is going to be relegated to mostly work and tow duty and daily errands and all that kind of stuff. But I want to be able to pull other people out with it. I don't really plan on sticking it. I've already abused that truck enough off-road. It's kind of time to, either that truck needs to die or it needs to not continue to be a roadworthy vehicle. Well, and we're going to keep it a roadworthy vehicle. I'm just saying I'm tired of throwing money at that dang thing. When you abuse it off-road, it just ends up, something breaks on it. It's not the Cummins that breaks. All right, we're going to move over there right now. I made another full-length video in regards to the Cummins bumper, so go ahead and check that out. It would have been too long to put it in here.